I am Neelam Mehra and today we are doing polynomials, right? Polynomials exercise 2.2. Now in 2.2 we have two questions and we'll do both of them one by one. The first question is, find the zeros of the following quadratic polynomials. We are given few quadratic polynomials and we have to find the zeros, right? The first thing, and then once we get our zeros, we have to verify the relationship between the zeros and the coefficient. We know there exists a standard relationship between zeros, or rather sum of zeros and product of zeros, and the coefficients. So we have to establish those relationships for all the polynomials given to us, right? So first is zeros and second is establish the relationship between zeros and the coefficient, right? So let's start doing the question. The first part being x square minus 2x minus 8, right? So we'll make it a quadratic equation to get our zeros. And as we've done in our 9th standard as well, we'll do it by splitting the middle term, that is x square. Here a middle term is 2x and we have to split it in such a way that the product will be first and the third term, that is 8x square, right? So what we can do is minus 4x plus 2x. What would be the answer? Minus 2x, right? And if you multiply it, it will be minus 8x square, which is nothing but first and third product, right? So we've just written 2x in the form of minus 4x plus 2x. Just splitted it in two terms, nothing else we've added or subtracted, right? Nothing else you've done. So here it is. Now let's solve it further. We can take common. It will be x minus 4, and here we can take 2 common. It will be x minus 4 equal to 0, right? Then further x minus 4 is common and we'll get x plus 2, 0, right? So if the product of two terms is 0, then either of them has to be 0. So if my x minus 4 is equal to 0, then x will be 4. And if my x plus 2 is 0, that will give me x as minus 2. So these are the zeros of my polynomial given, right? 4 and minus 2 are the zeros. So my first part is complete for my first question. And let's now establish the relationship between the zeros and the coefficients, right? Zeros are 4 and minus 2. Now to understand the relationship between zeros and coefficient, we need to see what are the coefficients of this particular quadratic polynomial. As you can see, coefficient is the fixed constant term with the variable with highest degree with x square is my a, minus 2 is my b, and minus 8 is my c, right? So my coefficients are 1, minus 2, minus 8, minus 2, minus 8, and 1, right? So these are my coefficients. So now let's find out the relationship and see if it is verified or not. So we know the relationship. We know sum of zeros is minus b by a, where my minus b is, this will be coefficient of x and a is coefficient of x square, right? So let's find out sum of these zeros, 4 and minus 2. This will be 2. And let's see if it is equal to minus b by a or not. We know my minus b is minus 2, so minus b is 2, right? So plus 2 we can always write like this, and a is 1, right? So minus and minus 2 is b by a. So here my sum of zeros relationship is established. We started with sum and we've reached to minus b by a. So the relationship between the zeros and coefficient established for the sum. Now let's establish it. Let's verify it for the product of zeros also. We know product of zeros for these concepts, why sum is minus b by a and why product of zeros is c by a. You can check out my video for the concepts, right? So product of 0 is c by a. Now let's do the product of zeros. We had 4 and we had minus 2, which will give me minus 8 or nothing, 1. So minus 8 is c, a is 1. So this is again established. Got it? My relationship between the zeros and coefficients established. Zeros are here, and here goes my first question. It's complete, right? So let's do the second part of the first question. So the second part of first question is 4s minus 4s square minus 4s plus 1, right? So let's do it again by middle term. We'll first query to 0 to find the values of my variable for which the whole equation is 0. So those are the zeros. So let's split the middle term. We'll split middle term 4s into 2s and 2s. So we'll get minus 4s, and if you multiply it, it will be plus 4s square, which is nothing but first and the third term product, right? And this is this exactly the way we did our first question. So we'll take whatever coming common, right? Then again we've taken 2s minus 1 common. We'll get 2s minus 1 inside. So either of them has to be 0. So if my 2s and minus 1 is 0, it will give me s equal to 1 by 2. The other 2s minus 1 if equal to 0, it will give me s equal to 1 by 2. So these are the zeros for this particular polynomial. Now let's find out the relationship. Let's verify the relationship. A is 4, B is minus 4, C is 1. Right? As we can see, A is 4, B is minus 4, C is 1. Right? 4 minus 4, 1. Always remember the equation you're solving. Before starting solving the equation, you have to get the equation in the standard format, which is term with the highest degree has to come first. The next term is with the variable with next level of degree, like 2s square is the first term, then s, and then the constant term. If any question is given, which I'm sure will be there in further question, that kind of problem will come up and we'll do it there. You have to arrange or shuffle the terms so that it comes in the standard format, right? So in quadratic polynomial, first the degree 2 s square, then s, and then last the constant term, and then we can get the coefficients. Now let's establish the relationships. We say sum of zeros is equal to minus b by a. We know minus b is coefficient of x or s in this case, and coefficient of s square here. So let's start with sum of zeros, half and half, right? 1 by 2 plus 1 by 2, right? So it will be nothing but 1 plus 1, 2, and it is 1. And if you can see minus b by a, minus b is minus of minus 4, that will be 4 oblique 4, that is 1, right? It's that only. But to get it in that format, we can multiply the whole equation by 4 by 4. We're not doing anything extra, we're just multiplying it by 1 only. 4 by 4 is nothing but 1. So it will give me 4 by 4, right? Or we can say minus of minus 4 by 4, which is nothing but minus of b by a, right? Then comes the product. My first relationship established, if you can see, product is 1 by 2 into 1 by 2, which gives my 1 by 4. 1 is c, a is 4, so this is nothing but c by a. So my other relationship is also established, because we know that product of zeros is c by a, which we are getting here, right? With this, our second question is done. Now let's do the third question. Our third question is 6x square minus 3 minus 7x, right? And let's do it. Again, we'll split the middle term. We have to, okay, one thing, we'll quickly shuffle the terms, because first it's a quadratic equation now. Now we know the standard pattern of quadratic equation is variable with highest degree, next level of degree, and the constant term. So 6x square minus 7x minus 3 is the standard pattern, ax square plus bx plus c, right? Now we'll start solving it. So always remember, have a look at the equation given, polynomial given, see if it is in the standard format of ax square plus bx plus c. If not, bring it in the standard format and then start doing it, right? So now we have to split minus 7x in such a way that the product should be minus 18x square, right? So let's do it. 6x square minus 7x, we can write minus 9x plus 2x. This is minus 7x, and if I multiply it is minus 18x square. Okay, so let's take common. We can take 3x here. It will be 2x minus 3. Again, there's nothing common, so it will be 2x minus 3 equal to 0, right? So either of, again, sorry, we'll take the common 2x minus 3. It will be 3x plus 1 equal to 0. So either 2x minus 3 is 0, which will give me x equal to plus 3 by 2, or 3x plus 1 is equal to 0, which will give me x equal to minus 1 by 3. So these are my zeros for the given polynomial, right? 3 by 2 and minus 1 by 3. Now we will do the relationship. 3 by 2 minus 1 by 3 are the zeros for this polynomial. Now let's find out the coefficients. This is the standard format, so A, B and C. 6 minus 7 and minus 3. A is 6, B is minus 7, C is minus 3. Right? So these are the coefficient. So let's find out verify the relationship. Sum of zeros we know is minus B by A. Let's find out the sum. 3 by 2 and minus 1 by 3, right? 3 by 2 plus minus 1 by 3, so we quickly skip one step. Minus 1 by 3, right? 3 by 2, 1 by 3. So we'll take it 6, 9 minus 2, this is 7 by 6. And if we say B by C, B by A, it's minus 7. And if we say minus B, it will be 7 by 6. So what we can do is minus 7. We can always write 7 as minus of minus 7. It is nothing but plus 7 only, right? So that is minus B, since B is minus 7 upon A. So our first relationship is established. It's verified. Now let's do the same thing for the product. Let's see if that is also correct here. Product of zeros we know is C by A. So product C by A. So product comes to my product zeros of the product 3 by 2 into minus 1 by 3. Right, which gives me 3 by 6. Minus 3 is C, A is 6. So this is C by A, right? So product of 0, we have started with multiplying as zeros and we have reached to C by A. So this relationship is verified. Similarly, sum of zeros relationship is also verified. So here's the answer, zeros and the relationship being verified, both the relationship being verified. So this is our third question. Let's go to the next question, fourth one. Let's do the fourth question. Our fourth question is, fourth part of the first question, I mean to say, is 4u square plus 8u, right? So just have a look at the equation given, polynomial given. Now an equation. It is not exactly in the standard format of ax square plus bx plus c, or is it? It is, just with a little difference that a is this, ax square is this, bx is this, and there is no constant term, c is 0, right? So when we'll solve it for the coefficient relationship, we know a is 4, b is 8 and c is 0. It's a normal quadratic polynomial, right? So since there is no middle term, there are no 3 terms, so we can easily solve it directly just by having a look at it. We can see something is common, so we can say u plus 2, right, equal to 0. That means 4u equal to 0 or u plus 2 equal to 0, which gives me the zeros, my zeros. This is u equal to 0 and u equal to minus 2. These are the zeros, u equal to minus 2 and u equal to 0, right? Now comes the relationship verification. We'll start with sum of zeros. 0 and minus 2 will be minus 2, and if you see our minus b, it's minus 8 by 4, right? So basically we're not doing nothing but multiplying the whole thing with 4 by 4, which is nothing but 1. So this will give me minus 8 by 4, which is my minus b by a. So my relationship is verified, right? I've not written the formula here because we've already done it for the first 3 questions, so you can directly do it. We know sum of zeros is minus b by a by now, right? So same will do for the product of zeros. We know the formula is C by A, so we have to reach to C by A, and then my relationship will be verified. So 0 into minus 2, which is nothing but 0, and my C is again 0, so it is C. Whatever A is, it doesn't matter, it will come to 0 only, so it is C by A, right? My C. So here's my relationship as verified. I have my zeros, so part 4 is done. Let's do the 5th question. The question is t square minus 15, right? Again, here in this quadratic equation, I have ax square, I have the constant term, the middle term bx is missing, right? So we can solve it not by middle term, but simply having a look at it, we can see how we can solve it. If you're looking at it, obviously one formula is striking me at the moment. We know a square minus b square is a plus b, a minus b, right? So here also that can be achieved by making root 15 square, which is nothing but 15, right, equal to 0. So we'll use the formula, we'll do t plus root 15 and t minus root 15, which will give me t equal to minus root 15 and t equal to root 15, which are my zeros for this quadratic polynomial, right? Now let's find out the relationship. Let's start with sum of zeros. Sum of zeros are root 15 minus root 15 plus root 15, which is 0. It gets cancelled, right? And if I see my b, my a is 1. Okay, let's quickly mention our a is 1, b is 0, c is minus 15. 1, 0 and minus 15, right? So we know b is 0, so we can write b by a. A is 1, but it doesn't matter, the answer will be 0 only, right? So even if it's like 0 by 1, it is b by a. It doesn't make a difference. And then product of zeros minus root 15 into root 15, right? So this will come as minus 15 by 1. My c is minus 15 and a is 1. So this is nothing but c by a. So aren't my relationships established between zeros and coefficient for this equation? They are. Sum of zeros, I've reached to minus b by a. I'm so sorry. 0 is like minus plus, it doesn't matter. And product of zeros is c by a, right? So here is my relationship established. And zeros we've got for question number 5th. Let's do 6th part of first question and the last part for this particular question. The question of question number 1 is 3x square minus x minus 4, right? So as we are doing it, we'll split the middle term, right? We can do it minus 4x plus 3x, right? So we're getting minus x, and if we multiply it, we're getting minus 12x square, first in the third term product. So we'll make it an equation, minus 4 equal to 0, right? Let's take common. 4 that is plus 3x minus 4, right? Then again something is common which can come out, and we'll have inside this, right? And which gives me 3x minus 4 equal to 0, which will be 4 by 3, right? Or x plus 1 if equal to 0, it will be x equal to minus 1. So these are my zeros for the polynomial 3x square minus x minus 4, right? So these are our zeros. Now let's find the relationship, verify the relationship between the zeros and coefficients, right? So we know, first we'll find out the coefficient, 3, minus 1 and minus 4. A is 3, B is minus 1 and C is minus 4, right? That's 4. So we know sum of zeros has to be minus B by A if the relationship holds good for this particular question. So let's see what is our sum, 4 by 3 and minus 1, right? Plus minus 1 by 1, which will give me 3. 4 minus 3, it will be 1 by 3, or we can say minus of minus 1, which is nothing but plus 1 only, upon 3, which is minus B upon A, right? So sum of zeros from where we started, the verification is done for sum of zeros. Now let's do for product of zeros, right? So we have 4 by 3 into minus 1, which will be minus 4 by 3, and as we can say, minus 4 is C and A is this, right? So product of zeros is equal to C by A. So this also is verified, the relationships. So with this we are done with our 6th question, and our first question of 2.2 is complete. I hope it's all clear to you. I'm sure it must be all clear to you. Very easy. We're just splitting the middle term to find out the zeros if there's a chance to split. If even simpler, we can solve it, you know, just by taking common. If you just have two numbers, you can't have the middle term splitting, then you can simply solve it to get the value of zeros, get the value of x for which my whole equation is equal to 0, right? That particular value of x is called zeros, and then you will verify whether sum of zeros is coming out to be minus b by a, and similarly product of zeros is c by a or not, right? So with this, our first question is done for 2.2. For the next question, let's check out the next video. My question number 2 will be in the next video. Thank you. Bye bye and all the best.